Hello and welcome back to INSEVIS Video-Tutorials. My name is Andy and today I'm showing you the Configstage. To download the Configstage, you go to insevis.com, to the download menu, to the point software, and you can download the zip file here. After the download has finished, you extract the zip file and execute the installer, which will then install the Configstage on your system. I have done so already and placed in a link here. So I will just open it. And this is the Configstage. Now inside the Configstage you add a new configuration, and from within here you can select your device. So you have your compact PLCs with no display and your panel PLCs with a display sorted by the display size. And as you see on the right, you always have a picture of your device, so you can easily identify it. I will just choose mine, PC717T, and hit OK. Inside the Configstage you have on the left side a project browser which shows your CPU, your connections and your periphery slots. In the middle you have a visual representation of the backside of your device, how you configured it. In the middle down you have a property section from which you can access all the settings of the different things you have selected right now. On the right side you have a catalog for central periphery, which you can slot into these slots, and also CAN periphery, which you can add to the CAN bus. Down here is a simple information for the modules. So starting with the device itself, you have your general information here, nothing much to access, but you have for example down here a simple description of your CPU. If we go to the CPU, you can have a few more settings. You can set the name and the designation of your device. You can specify startup and diagnostic settings. You can set the protection level. You can set the communication to your PG. You can set the cycle settings, so the monitoring time, the scan cycle load for communication, and so on. You can set the clock settings, retentive memory, time of day interrupt, cyclic interrupts, which you can access inside your S7 program with these names, and a simple web server which is available on the T CPUs. Going on to RS232 or serial, you have simple settings for the baud rate, data format, and protocol. For plain ASCII, that's it. But if you switch to ASCII with defined encode, you can automatically detect encode characters such as carriage return, for example, and select to do so here. So either on the end of a delay time or on the receiving of end characters. So one character in hex in ASCII code, or two characters in hex. Moving on to RS485, you have basically the same settings if you stay with ASCII, so baud rate, data format, protocol. But in here you can switch to Modbus RTU, and now you can configure a complete Modbus server. And the special about this is if you tick that box and run the configuration to your device, you now have a complete Modbus RTU server. You don't need a S7 program to back it up. Everything you set in here will be executed by the server with no further configuration. So you set your discrete inputs and outputs, your registers and so on with the byte offsets and the lengths, and your server will publish these addresses over Modbus RTU. Moving on to Ethernet, we have a CPU type T here. This means we've got 2 Ethernet ports. If you got, for example, type V, you've got only 1 Ethernet port. The 2 Ethernet ports are especially useful if you want to separate your machine nets from your service net. If you have, for example, an external service technician who has to service your machine, you can let him only in on one net and from the service net, and your actual machine net is protected if you don't trust him fully, for example. You can do so if you by choosing the operation mode here. So if you got the 2-port Ethernet switch, this means the 2 ports are basically in the same net with the same IP address. So nothing special here. But if you separate them, you've got 2 separate IP addresses for the connectors. And with this, you can, as I just explained, separate your nets for security reasons. If you go down here, you can set your IP protocol, so the IP address itself, net mask and router address, just like in every basic network configuration. And also you can protect your device from the S7 communication access on both ports separately. Down here, you add connections over Ethernet. If you want to communicate between PLCs with S7 put get, for example, you would add a connection here. Also, if you add one here and search for the type, we again have a Modbus TCP server, which works in about the same way as the RS485 one. So you just select your input and output bits and your registers, click on OK, or you select your Ethernet interfaces on which you want the server to run. Click OK, and now you've got a fully functional Modbus TCP server without an S7 program. If you add a normal connection in here, so a simple S7 connection, enter your communications inside here. So if you want to communicate with a specific PLC, you would type the IP address in here, rec, slot, connection, resource, and so on. Hit OK. And now you see you've got an ID in front of here. And this is used inside the S7 program. If you want to actually send data over this connection, you would use this ID inside the function block. To use these functions here, we have collected functions and function blocks inside an S7 library, which you can also download from the website. How you do this and how you install it, I've shown you in a different video you can find on this channel. Moving on to CAN. CAN is also especially simple. You see you have only one setting and that's it, because it is that simple in here. You can, if you use decentral periphery, you can use decentral periphery from us. So they are called DP and then a number back here, which specify the number of periphery slots you have. If I would add a DP307C, this means I got 7 periphery module on this CAN device. And all you have to do, you grab it with your mouse and pull it onto the CAN interface on this connector. And now it is connected. And what you have to do on your actual device later on, you have to connect the cables and set your node ID you see in here on these rotary dials on top of the device, and that's it. Now your CAN is running. That's all you have to do. It's that simple. If you want to use different CAN objects, you can do so. We have a small selection of pre-configured CAN devices. You could also just grab and pull on here. But if it's likely your device is not with these devices, so now you can create an own one. To do so, you select the device called CAN node, put it here, configure it with your PDOs and so on. You can make this simple by importing an EDS file from your manufacturer, and if you're happy with the result, you can store it inside the library. So if you do later on a similar configuration for a different device, you can reuse your CAN device. How this all works, I show you in a different video you can also find on this channel. So moving on to the periphery slots themselves, you can, again, it's drag and drop again. I choose my periphery modules. Maybe I DIO in here and goes for some analogs. All right, maybe not a mixed one. And you see I have left, well, actually, let's delete the mixed one. If you got a relay module, there's a little bit specialty. It's DO4R, and if you put it in, you see it has these round little breakers inside for your protection, but you have to be able to access them to change them if something happens. And because of this, on top of the housing of the PLC, there are round holes inside, and these are only present on the last 3 slots. So you are not able to place the DO4R in this slot, for example, only the last 3 slots. But this is only a minor restriction here. So again, go on with populating them. So now we have our PLC fully maxed out, and as you're probably aware, I have just pulled them in random order. Now if you have done so like me and you don't know where all your addresses are and everything is all over the place, you can go to View, Address Overview, and now you see which module occupies which address space and which slot on your PLC. This is also true if you have CAN periphery over our decentral periphery and which address space is occupied by these periphery modules. So inside here you could just double click and it shows you, okay, you have to change in here, and you can also view address conflicts. So this is a very quick and easy way to sort out your addresses. Let's have a look on the periphery modules themselves. We start with the digital I/O. You have basically a start address and for the input and output, and down here you can configure your channels. And one specialty of the digital periphery modules is you can choose the type of the channel for each bit individually. So if I disable the output for the first 3, these are only inputs, and maybe I'd like this one and this one over here. So they are, you don't have to configure them in whole bytes. You can go every bit differently. This is also present over all the different other modules. If you have like the mixed I/O, there is the digital part in the mixed I/O, and you can reconfigure them also bitwise. If we go for the analog, this is a analog I/O card for in, for out. You have again your input start address, and for analog specialty is the integration time, which means this is the time the module takes to measure an analog value. And the longer the time, the steadier your value will be, but you need longer time to measure, so you have to make a trade-off between accuracy and speed. For each input channel, you can select in here the mode in which you would like to measure, so your voltage or current, and again the same for output start address and measuring mode. If you go to the mixed I/O, it's a bit different. You can change the analog channel wise from input to output as you like, and in there from measurement type as you like. If you're happy with your result and you want to upload your configuration to your PLC, you can do so over here. Just hit transfer and it will upload the configuration to your PLC. And at this point, without visualization and S7 program or something else, just configuration, you are able to view the inputs inside, for example, TIA portal or Semantic Manager. You can just connect in there to your device and open up the view table and have a look at your inputs, so you see if everything is configured correctly and works. That's all from me. Thanks for listening. If you enjoyed it, give me a like, share this video with your colleagues and hit the subscribe button so you won't miss a single tutorial.